In this video, we will be solving rational equations and answering the essential question, what features of the equation do you look for when deciding which method to use for solving a rational equation? So the first thing that we should probably discuss is what a rational equation is. A rational equation is any equation, right, an equal sign is in the equation, where you have a fraction that contains a variable. Specifically, that variable would be located in the denominator of the equation. So we have two different types of rational equations illustrated here. The first type is we have 3 over x plus 1 equals 9 over 4x plus 5. We have a single rational expression set equal to a single rational expression. We have one single rational expression on each side of the equal sign. When we have this scenario, we want to make sure that we're going to use our cross multiplication method when each side of the equation is a single rational expression. So when you see something set up like this, you want to cross multiply to solve. Now the other type of rational equation that we're going to encounter is one where instead of having a single rational equation on each side of the equal sign, we would have a combination of rational expressions being added, subtracted, perhaps multiplied or divided to each other. But in either case, we don't have a single rational expression anymore. We have two or more on one side. So whenever we have a situation like this, where you have more than one rational expression on one side of the equation, you want to multiply by the least common denominator. We'll be doing an example of that in the second video. If you haven't written these two examples down and the method in which they need to be solved, please pause the video at this time and get these concepts down into your notebook. The equation we will be solving and demonstrating in this video is the cross multiplication method of solving a rational equation. So cross multiplication, what I mean by that is we're going to take the denominator of the second fraction and multiply it to the numerator of the first fraction. So when we do that, we would have, let's see, this 3 needs to be multiplied by 4x plus 5 and equals, now the other side would be the denominator of the first fraction multiplied by the numerator of the second fraction. So here we would have 9 times x plus 1. So cross multiplication. So I have set up the multiplication of each side of this equation, and now I just need to follow through with the multiplication. So 3 needs to be multiplied to the 4 in the x, which would result in 12x. 3 also needs to be multiplied to the positive 5, so we'd have positive 15. Equals, now we'd multiply the 9 times the x and the 9 times the 1. So that'd leave us with 9x plus 9. So now we have two linear equations on each side of the equal sign. I don't have fractions anymore. This problem is much less intimidating. Now my goal when solving is always to get x by itself. So I say I have a 12x on the left side of the equal sign and a 9x on the right side of the equal sign. So I want to move one to the other. I personally would move the smaller valued x value to the other side. So 9x is smaller than 12x. So I would subtract 9x from each side of the equal sign. And that's what that yellow bar there is for. When I say left and right, I'm referring to the left and right of the equal sign. So 12x minus 9x is 3x. I still have the plus 15 equals, and on the right side, I'm left with 9. Now I only have a single x, but it is on one side, but I still have a 3 attached to it by multiplication and a 15 attached to it by addition. So the weaker of those two operations is the addition, so the inverse of that would be to subtract 15. So that would leave me with, let's see, let's get some more space here. On the left side of the equal sign, the positive 15 and negative 15 would cancel, leaving me with 3x equals, and 9 minus 15 is negative 6. Now the 3 is being attached to the x by multiplication, so the inverse of that to cancel would be to divide by that 3. 3 divided by 3 is 1, and 1 times x is just x, equals, and then negative 6 divided by 3 is negative 2.